Welcome to Flip Lesson 101. Getting up into those three-digit numbers as we work with our lessons now. Today we're looking at the idea of ratios and the idea of totals and how this relationship works together. So basically we're using ratio boxes, ratio squares, which we've kind of played around with these a little bit. I think we did this together with the idea of proportions. All right, and dealing with class size and proportions. And ratios, of course, works in a very, very similar way, though sometimes our numbers are reduced or sometimes our numbers are a little bit, well, a little bit more, I don't know, mathematical? I don't know if that's really the right word, but let's go with it. A little bit more mathematical. So today what we want to do is we want to look at how this actually works. Sometimes we're given a ratio such as a store has, for every 3 rabbits, it has 5 turtles. And as we look at that idea, the question would be, well, how many rabbits is that, or how many turtles is that if you have 64 total animals? So how many rabbits is it and how many turtles is that? So to solve this, to find our missing ideas, right, how many rabbits, how many turtles, we're going to use our ratios to help us understand this concept. So I'm going to go ahead and extend the page a little bit and we'll take a look at this then. All right, we're going to use what we understand, right? And we can solve this in either order, but I'm going to go ahead and start with rabbits, right? I know there are 3 rabbits out of the total of 8 animals. And so I have this fractional ratio to help me understand what's going on. All right. And because I know this is the ratio, this 3/8 here is the ratio, I know that's going to be equal to the total on the other side. And so what I'm really looking for is this idea right here. So how do I go about solving that? There's a couple different processes that we can use, right? Proportionally, we can talk about just the relationship straight across, because that relationship is going to be, of course, straight across like that. That's what the equal sign is all about. The other process that we look at, if we can't see that relationship straight across, right, is to use the relationship of cross multiplication and division. So there's 2 processes that we can follow here. All right, now, in this case, we can definitely see a relationship between the 8 and the 64, so we can go ahead and use that relationship to help us understand. We know that 8 times 8 equals 64. Since those 2 are connected, we can also say that 3 times 8 is going to give us 24 rabbits. So we have, well, that's not a good B. We have that idea. All right, from here, we can do a number of different steps then to figure out how many turtles we actually have. We can take our total of 64 and we can subtract our 24 rabbits, and that should give us a total of 40 turtles. And we can double check our work by doing the same process, right? 5 over 8 is equal to something over 64. And once again, 8 to 64, that relationship is 8. So 5 times 8 can give us the answer of 40. So our answer definitely agrees. So there are 24 rabbits and 40 turtles. So we have that idea. Right. Sometimes, however, the information isn't so neat and clean, right? There's more blanks, there's more things going on, and so there are different ideas that we need to figure out, okay? First of all, we can look at this box, right? A ratio of boys to girls and the relationship that we're seeing here. So we need to know how many boys there are, and we need to know how many totals are, and of course we need to know the ratio number. Now we can start here by doing really what I would say is the easiest step, right? The ratio total is a combination of this number plus this number. So right now you really have 2 plus x equals 7. And that, of course, is a very easy mental math problem. You can figure that out. You've been doing that for years, and you can plug in that 5 right there. Right? So that box is not too difficult to do. But then on the other side, we can start to look at our relationships and understand how to solve these different parts, okay? Because we need like ideas. We can't just start plugging things in. So the first thing we need is we need that 5 there to help us understand what's going on. So if I want to know the total number of boys, right, I'm going to put 2 over my ratio of 5 this time. I need to use 5 because my other number is 20, right? And 5 goes with 20. So that relationship needs to be the same, right? Got to have the same things on the same parts of the fraction, right? I can't have the 5 here and the 20 up here, right? Because that would say 2 has the relationship with 20, right? So we can't do that. So in this case, we have it all set up. We're able to solve. We can see the relationship between 5 and 20. We're going to multiply by 4 on both, and we're going to get a total of 8, right? And then, of course, our actual count, our total, right? So this should be 28, and we can double check our work by solving for this to see if there is a relationship, right? So basically, right, I could even mix this up, right? 5 over 7 is equal to, but now I got to have the same ideas, right? 20, right? 5 goes with 20 over, right? Before we had an unknown of 28, right? We weren't quite sure, but if we're double checking our work, right, we're going to be multiplying times 4, and of course, we're going to very easily agree that yes, this is 28, just like that, all right? So we have these different ideas. All right, here's your sample problem to work with our first look at ratio squares. I don't know. That might not be the right word. But let's just talk about using ratios to solve problems. Go ahead and do our sample problem. That's the end of lesson 101.